Do you hear me? All right. Good morning, Nur Farah, Siti Rokia. Good morning. Okay. Others, good morning. All right. Good morning. Do you hear me? All right. All right. Good morning, Nur Farah, Siti Rokia. Good morning. All right. Okay. Others, good morning. All right. Okay. Let's we continue the class today. Okay. Before that. All right. All right. Good morning, Nur Farah, Siti Rokia. All right, so now I'm sharing you the notes that you can get from e-learning. Go to the e-learning. Okay, we go to e-learning. All right. Stop sharing. Okay, I go to the e-learning. All right. Okay, I'm showing you the e-learning. Okay, this is where we are. You go to numerical method 2, chapter 1, single step and multi-step method. Single step and multi-step method. Right? Okay, go to the e-learning. Okay, and then go to the numerical 2, chapter 1, single step and multi-step method for initial value problem. All right, we learn in chapter 8 and chapter 9. Okay, you go to the numerical method chapter 1 here. All right, you can get the previous chapters, chapter 8 and chapter 9. We go to chapter 8 and chapter 6. Chapter 6 for numerical differentiation, chapter 8 for ordinary differential equation. All right. For chapter 2, in numerical 2, now our subject is a nonlinear system of equation. You go to, please go to chapter 1, okay, in numerical 1. All right, so we just play around with the previous note in numerical 1, chapter 1, chapter 8 and chapter 6. All right, so please remember the notes. Okay, but we want to go further now in chapter 2, okay, in numerical 2, chapter 1. All right, so now I'm stop sharing. I want to go to, okay, stop sharing. I want to go to another chapters, okay, where is chapter 1. All right, so we go to the Windows and all right, this is a chapter 1. I share again chapter 1. All right. Okay, go to your e-learning. Okay, please go to your e-learning. Okay, and then find nonlinear equation chapter 1 through the e-learning. I'm waiting for you. At the same time, please scan your QR code. Okay, scan the QR code. All right, when you scan the QR code, all right, okay, at your Telegram, okay, we are going to confirm your attendance toward the ends of this class. There is some exercise, okay, where you need to post on time, okay, and then we need to post the end of our close for confirm your QR code at the Telegram. Okay, you can post before 9:30 today, 9:30 morning today. All right. Okay. I'm going to give the some task to you the ends of this class. Okay. All right. So now, okay. I'm going to go for e-notes. Okay, we go through first the e-note at e-learning. Okay, because we need to explore, okay, introduce the non-linear system of equation, where is an enhancement chapter 1, okay, for numerical 1. Chapter 1 is a non-linear system of equation. All right, in chapter 1, okay, I make it more bigger. Okay, in chapter 1 that you learn in numerical, okay, 1 is finding a root. Okay, there are many ways to find a root. Okay, for example, you can use bisection method, you can use also fall position method, fixed point iterative method, Newton method. You still remember? All right, very good. All right, I just want to remind you again and again. And then, okay, we use the formula intermediate value theorem. Okay, this is to show your graph. Where is the location of the root? Okay, the location of the root is between A and B. A is a initial, okay, of the interval, and B is the last, okay, last point of the interval. All right, so the root here is between 0 and 1. The root here is between 0 and 1. All right, so I just want to remind you, okay, again and again. All right, and then, okay, we have a theorem, okay, to find the root. Okay, we call as an intermediate value theorem. Okay, the formula is, if you have the interval between A and B just now, okay, you see here, okay, the graph A is 0 and B is 1. All right, come back again. A is 0, B is 1. Okay, come back again. Okay, between the interval, the first interval A is 0 and B is equal to 1. Still, I just want to remind you, okay, this is not the class. You have the notes before, the same notes that you refer in chapter 1. All right, so now, okay, since we have the formula of intermediate value theorem, what is the formula? Okay, is if f is the value of y exists, if f is equal to 0, so that is a root. But if f, okay, for A and f for C is a changing point, is less than 0, so you need to find the new interval. If C is a moving, okay, point where is close to the root, times B less than 0, so you need to change the interval, okay, the interval, the size, the duration, okay, the size of interval. So that's we learn. All right, so now, okay, based on this information, we can solve many methods, okay, to find a root, right, for nonlinear system of equation. What is a nonlinear system of equation? Okay, you see the graph here is a curve. Okay, it's not linear. Okay, it's like a sinus function, cosinus function. It's not linear. All right, this is the curve function. All right, so to find a root is difficult. Why? Because, okay, the graph is sometimes exponential function. Ln is, okay, there is a root in the curve, okay, which is across the x-axis. So how to solve this problem? In numerical, it's very easy because we ask you to use a calculator. Okay, if you have a calculator, okay, use your calculator, and then I, okay, express here. There are so many ways to use a calculator. All right, so I change my sharing. Okay, I hope I'm stop sharing. I share again. Okay, how to use your calculator. Okay, where is your calculator? Please put aside your calculator. Okay. All right, so the tool for numerical is a simulation, is a computational, is to calculate, okay, to simulate, all right, to execute, all right. So to do the execution, you need to have a calculator, all right. So you can see here, okay, view more. All right, I will send also to your e-learning or to your Telegram, okay, about the how to press your calculator. All right, so this is the the link that you can use to the way how to use your calculator. All right, so I'm going to share with you at the um, Telegram, okay, after this, okay. You can use a simultaneous equation for linear equation, integral, find the factors, okay, using the calculator. Okay, at this moment, okay, we are using 4 decimal places. How to press 4 decimal places? Keep in mind mood fix 4. All right, please press mood fix 4. All right, okay. So if I said that I want you to solve the problem based on 4 decimal places, 2 decimal places, okay, so you just press mood fix 4 or mood fix 3. All right, I will send you this YouTube to show you how to press your calculator, how to do the sum function. All right, and then how to change from radian, okay, to decimal places, okay, decimal places to radian. If you deal with the trigonometry function, please keep in mind. All right, okay, now, okay, I'm stop sharing. Okay, I give the material at the e-learning or your Telegram. All right, okay, now, all right, so okay, it's coming. Okay, there is a coming here. Intan, good morning, Intan. All right, good morning. Okay, I saw okay your information at the Padlet. Thank you very much. You submit on time. Okay, why we need to submit on time? Okay, I remind you again. You can see at the Telegram because we want to reduce the usefulness of the live online tutor. What is a live online tutor? Means that you get the somebody to help you, okay, during the examination, during the test, during the running, okay, completing your assignment. So to solve this problem, I hope that, okay, you can solve, okay, you can complete your task during a class or 15 minutes after the class. Okay, for example, we have the exercise, okay, after this to confirm your QR code. All right, so you need to complete, okay, 15 minutes after the class or during the class. All right, so I give you a time. So it's very fast. If you have a low connection, you can get help from your friend because now we are implementing active learning, all right, where you work in group. You are work in group, all right. So this is the way, okay, how I can solve the problem during online teaching and learning. Okay, all right, very good. Okay, coming as also Khairuna. Okay, thank you very much for joining the class and confirm the 2 ways, okay, of your QR code. All right. Okay, now, okay, let's we continue. Okay, our subject. Okay, I want to focus on this. Okay, this subject. All right. So let's we share screen. Okay. I'm sorry. I'm quite active in sharing my screen. You know why? Okay, because okay, we have the e-content. All right. When we have e-content, so it means that you just refer to e-content. All right, and then where is my chapter 1 video? Mm-hmm. All right, I hope I can share this one. Okay. All right. Okay, this one is a chapter 1. Okay, you look and see. All right, so this is our subject. Okay, you go to the e-learning. All right, you find chapter 1 for numerical 2. Okay, it's about initial value problem of the ordinary differential equation. All right, so okay, this is extent that you have a basic knowledge on numerical 1, how to solve the nonlinear system of equation. All right, so in this case, we are dealing with the chapter 8 ordinary differential equation. We are dealing with the ordinary differential equation. I make it more bigger, okay, and then let's if I can close here. All right, okay, cannot. So you focus on this, okay. The big, I think this is a very big, okay, writing here. All right, so there is few method to solve ordinary differential equation. Okay, what is that? Okay, it's a Bernoulli, Airy, Bessel, and Van de Poel equation. All right. So keep in your mind. Okay, what is an ordinary differential equation? Because okay, you don't know. Okay, what is an ordinary differential equation? Ordinary differential equation is related to the function of one parameter. For example, y is depend on x. Okay. Okay, there is no more, okay, parameters, for example, time involved here. Just y depends on x. Okay, for example, okay, temperature behavior of this room is depend on the how fast, okay, how fast the air, okay, or the how small the room to afford the temperature. All right. So now the second is a Bessel. Okay, Bessel equation. Okay, you can see here is a second order. Okay, you still remember again. We have a higher order of the ordinary differential equation. Okay, first order, second order, third order. So this is the first order of the ODE. This one is a second order of ODE. You learn second order, okay, of the partial differential equation on parabolic equation, hyperbolic equation, in elliptic equation in chapter 9. Okay, you know about the second order, and then you also use second order, third order, all right, of the ODE to find the, okay, you still remember Taylor series to represent the first derivative, second derivative. All right, so you are using Taylor series. Taylor series is how fast, how converge, how accurate solving the ODE up to the 4 degree, 3 degree, okay, 2 degree of the solution. That once you learn in chapter 9 and 8 in numerical 1. All right, so I'm stop sharing. Okay, why? Because I just want you to remember what you learn, okay, in chapter 8 before this. Okay, if I can see, all right, if I can share with you the material. Okay, go to the material. Okay, I'm going to give you this material at the e-learning, all right, or at the all right, your telegram, all right. All right, so now let's okay, focus this one. Okay, if I can focus this one. All right. Okay. I focus this one first. All right. Okay, okay, you can see here. Okay, you can see here. Okay, we learn ordinary differential equation using Euler method. Still remember, Taylor methods, Ranch-Kata method. So you know already about the ordinary differential equation here, right? So now if I can, okay, explain here, your function is to find the value of dy over the x equal to fx. So your function is to get the point of y. All right. For example, y1, y2, y3, y4, yn. All right. And then, okay, to solve this ordinary differential equation, what should you do? Okay, you need to know the interval between A and B. All right, so I put as a x0, x1, x2, and xn. To get n is grid at the x-axis. Okay, the formula is b minus a divided by h. Okay, you still remember, all right? Okay, h is a size of interval, n is a number of grid, okay, that you want to find. Okay, you still remember again about the Euler method where you are using the first order of Taylor series. What is the first order of the Taylor series? Yi plus 1 equal to yi plus h f prime xi yi. You learned already in chapter 8, all right? Okay, you can go to the notes at the e-learning. I already stated, okay, the notes at the e-learning numerical 1. All right, so your function here is to repeat, okay, use repeatedly, iteratively the formula of yi plus 1 equal to yi plus h f prime x I y I. Okay, first order Taylor series. You can extend this formula to the Taylor series and Ranskata higher order. All right, so remember, right? Okay, I just want to remind you again. All right, because the Euler method Ranch kata is iterative, we can stop the iteration by controlling the error. All right, the error is yi plus 1 minus yi less than epsilon. What is epsilon? All right, you go to the chapter 8. Epsilon is a convergent criterion to control the iteration. All right. All right, so now we go to the one of the simplest example. They are giving you y prime equal to x plus xy. This is only the ordinary differential equation order 1. So this you need to explain, all right? Please explain ordinary differential equation order 1 with the initial condition y when x equal to 0, y is equal to 1. Okay, you always set that as a y not equal to 1. All right, they put the solution at the small size of interval between 0 and 2. Very small, okay? Between the 0 and 2, you need to find the value of y. Meaning that, the intention for you to draw the graph. How to draw the graph? All right. So this is a question. Okay, how to draw the graph? All right. So now, to draw how? Okay, my question here is how? Okay, to draw. This you need to think. Okay, the graph. Okay, the graph of ordinary differential equation solution. Okay, ordinary differential equation solution. All right, so what types of the you can answer me through the top chat. Okay, you can answer me through the top chat here. Okay, I just want to ask you a simple question. All right, how to draw the graph of this question? Okay, ordinary differential equation, first order derivative. All right, so please, if you want to answer, let me know. Okay, the way to solve this graph, there is a few steps. Okay, the first is find the domain, because the domain now is between 0 and 2, between A and B. Okay, that's you need to know. How to find the domain? All right, you need to use the formula H equal to B minus A divided by N that I wrote before. All right, so you can, yes, remember, very good. Okay, very good. But Trisha, okay, very good. You still remember. I just want to remind you again, because we want to go, all right, we want to go for the advanced solving ordinary differential equation. Very good. So yes, you are, remember, okay. And then the second is find yi and xi. You know how to find xi by using the h. H is a size of interval, and n is a number of interval in the solution. All right, so now so let's we go to the other solution. Okay, I'm stop sharing. All right, I go to another our notes. Okay, I will go since you remember this formula, still remember the way how we solve the ordinary differential equation using tellers, and then you just I just will remind you, after this you know how to solve ordinary differential equation using Taylor series, and then Ranch kata and so on. Very good. All right, go to the e-learning and please download the notes. Okay, but now we want to solve this problem using Bernoulli equation. Wow, Airy equation. Wow, Bessel function and Van de Poel equation. That is our problem. Okay, never mind. Let's we go. All right. Okay, so let's we go for the overview of our chapter 1. Okay, in chapter 1, okay, you can see here we need to know what is the initial value problem. Okay, initial value problem. What is that? There is a condition. What is the condition? Is when x equal to the initial point x naught, y is equal to y naught. All right, so they should be given this condition, and then they're also given us the size of interval. Okay, what is that? The size of interval. Okay, I put more bigger. Okay, so make you clear. Okay, what is the size of interval? Is a difference between the 2 point xi plus 1 and xi. All right, so you can remember. All right, alhamdulillah. Now, okay, there are so many ways to solve the initial value problem of the ordinary differential equation. So now it's time for you to go to numerical 1, chapter 6 and chapter 8. All right, go to the e-learning, go visit the chapter 1 and chapter 8, because you learned already the size of interval, the number of interval, n is what? N is the number of grid involved. All right, and then n is to control the grid. All right, I need to find the size of grid, the small size of grid. Make sure that you can answer the question in 15 minutes. All right, so I control the n. All right, so you learned before using one-step method. Okay, you learned already. I just explained about Euler method. All right, and then extend to a higher order of the derivative using Taylor series method and Ranch kata method. Ranch kata method is the way how to make Taylor series with higher order. All right, in the simple form. All right, so that's why we use Ranch kata method. Why Ranch kata method? Because Ranch kata, they put the one step as a simple way. We are going to learn after this. All right, so Ranch kata is the simplest to make simplified of Taylor series. Taylor series is a basic to solve the ordinary differential equation, and Euler series is a Taylor series order one. All right, so you can make a story, all right, about the comparison, about the differences of the Taylor series, Euler series, and Ranch kata. All right. Anyway, we can say that the Ranch kata is much more accurate compared to the Euler, because Euler is a Taylor series order one. All right. Taylor series is much more accurate than Ranch kata, because Taylor series can be extended to higher order derivative. All right. So now, okay, we learned already Taylor series. You go to chapter 8, we learned already Taylor series, but in chapter 8, we just focus Taylor series up to order 3. Sometime order 4. It is just to make sure you can solve this problem in a few times, maybe in 50 minutes. So we control the order of the Taylor series. We control the order of the Taylor series. All right, I'm going to give you the link at the YouTube how we solve the ordinary using Taylor series in numerical 1. I will give you. All right, never mind. So now, all right, so since we know that Taylor series is approximate, approximate yi plus hyi prime. This one is a Euler. This one is a Euler method. When we extend to second order, h squared divided by 2 factorial y prime prime. This is a Taylor series order 2. Extend again, up to the OH power 4 is we call as a teleseries order 3. And then if you are going to use all up to n order, we call as a teleseries order n. So the issue here is how about the accuracy? The preciousness, the accurate, all right, of the teleseries. When you increase the order, of course, the teleseries contribute to the high computational and high accuracy. That's you learn in the chapter 8, numerical 1. All right. So now, again, we are again and again, all right, we want to solve this problem using teleseries. All right. So if I can find, you can go here. Please, look the question. You go to the notes first. All right. All right, so now I'm stop sharing, because we want to solve this problem using teleseries. I'm stop sharing. All right, so now there is a feedback from our friend here. Let's visit. Doctor, just press the top left icon bar to close the preview pages. Thank you very much. Thank you very much for remind me. All right, thank you very much for remind me. So now I want to stop sharing. I want to show to you how to solve the problem using teleseries. This is only to remind you, all right? There is not a new things, all right? All right, so now let's share. All right. Let's go the because the teleseries equation. All right, to show the teleseries. So I hope I can make it more smaller here. All right, so now all right, so this is a teleseries, that I told you is a yi equal to yi plus h yi prime plus h squared yi prime prime, all right, and then plus h squared, right? Plus h power 3 divided by 3 factorial, all right? You can see here. All right. Up to fourth order of the teleseries. You know how to write it. H power 4 divided by 4 factorial yi prime prime prime. All right. So, and then up to the n, order of the teleseries. And then the two ways that you need to remember is a teleseries is what we call is a higher order, all right? And then you can see here the teleseries is very important, because this more accurate to solve the ordinary differential equation. Right. From here, you can also see that the teleseries that we were going to solve for numerical 1 is up to order 3. All right. So order 3 means that the teleseries is yi plus 1 equal to yi plus h yi prime plus h squared divided by 2 factorial yi prime prime prime. All right. Okay, this is a order 3 Taylor series. Okay, this always you know, okay, because you solve the question in your final exam. Okay, up to, okay, maybe question number 4 is about chapter 8, how you solve ordinary differential equation using Taylor series. Okay, Euler method, okay, that I told you is a first order of the Taylor series. Okay, is a first order of the Taylor series. Okay, means that up to yi prime. All right. So okay. So now the problem here, we how we want to use this method to solve the ordinary differential equation. All right. So in chapter 1, we always assume that fxy equal to f prime x. All right. So we just assume the first order of the ODE is a fxy. Right. So this is a set in your mind. Okay, so for the range kata, okay, is that you implement in numerical 1 is a Taylor series order 4. All right, so that's why you said that you can solve ordinary differential equation using range kata order 2. You can solve ordinary differential equation for the range kata order 4. All right, okay, you already okay solve the ordinary based on those method. Okay, Taylor series, Euler and Ranjkata, order 2 and order 4. All right. So, okay. So in numerical 1, okay, you look here based on the Ranjkata order 4, you stop. Okay, you have capable to solve ordinary differential equation using Taylor series order 4. All right. This is the maximum okay order that you implement. Okay. So now you can go straight, okay, for this you can continue this video, okay, how we put some example, okay, to solve the problem of ODE using Taylor series. This is just to remind you. All right, so I'm going to send to your telegram, to your e-learning, okay, to make sure that you know about how to solve ordinary differential equation with the Taylor series. Okay. 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 Since we know that the Taylor series involving first order, second order, and third order. All right. So you need to come back to chapter 6, how you differentiate. Okay, first order, second order derivative. Okay, chapter 6, how we solve the problem using the first order, second order, and third order derivative. Yeah. All right. So that's you learn in chapter 6. All right, so now you can go to this video and learn based on self-determined learning, student-centered learning. Okay, self-determined learning and student-centered learning. If you have a problem, okay, about this video, all right, so you can talk in your group. So I'm stop sharing. Okay, I'm stop sharing because we are going to continue. Okay, this video based on the e-notes at the e-learning, based on the YouTube. Okay, the video that you learn. Okay, in the numerical 1, this is just to remind you. Okay, if you have a problem, I'm stop sharing here. Right, I want to share with you. Okay, one of the our task here. Okay, what is our task? Okay, I want to go to this. Okay, I sharing to you. All right. All right. So since you are in section 2 and section 3, I left if I can go to section. Okay, section 2. All right. So I sharing again. All right. I'm stop sharing. I go to section 2. Okay. For example, okay, you can also go to the section 3. Okay. Okay, the link I will give you at the telegram. All right, so you look here. Okay, look first. Okay. All right. Go to your Telegram. Okay, I already post the link, okay, at the Telegram. All right. So go to the Telegram. You can see the link. Okay. Go to Telegram. Visit your Telegram. Right. When you visit the Telegram, there is a link, and then start discuss in your group. All right. And then fill a form here. Okay. At the Padlet. For example, group one. Okay. Group one. And then please edit, okay, your group name, and then the leader of the group, and then please, okay, find your 4 members only in one group. So create, okay, for example, here you want to have a new group, okay, group 4, all right. And then the same thing, okay, please insert your leader, okay, leader, and then please write the 4 members only, okay, 4 members only, all right. All right, okay, because we can, the group cannot work more than 4, all right. So better, meaning that include the leader is a 5, and then your group name, okay, and your group name. All right, so you can okay, talk with your friend, go to the Telegram, communicate with your friend, find a group, all right, and then fill in the form at the Padlet to get the link. Go to the Telegram, you can get the link. I'm also post at the e-learning, all right, to make sure that you can solve this problem. Okay, this problem you can create the group, okay, till 9:15. All right, so people who are in the group is confirmed that your attendance at the QR code is as is, all right, is comparative, is a match, all right. So make sure that, okay, you start, okay, work in your group, okay, create the link in the group. For example, you can create a sub, okay, Telegram, okay, Telegram group, okay, and then, okay, what you do is create a group, okay, create a group, okay, social media, what we call is social media. For example, you can use Telegram, okay, you can use also WhatsApp, okay, you can use also WhatsApp, okay, to make sure that you can communicate in your group, especially if I give you a question and then you discuss in the group, all right, and then submit a group, okay, in 15 minutes. Okay, so this is very important. Why? Because you need to have your own group, 5 members in the group, all right, and then make sure also, okay, you have a group. If you don't have a group, all right, let me know, because we want to make sure that you are always in the group, especially to do a submission, okay, especially if you want to submit something, all right. I give you a task, I give you assignment, a group assignment, I give you okay, many style, okay, many style, okay, question to make you understand, okay, the subject, and solve this problem in 50 minutes. So this is a task, all right. Why? That I told you, we want to avoid, okay, you deal with the live active tutor outside, all right. So this is what we call as effort, okay, to understand the subject, all right, and then we can ask the question from the previous subject in the 15 minutes, okay, you submit the answer at the cloud. Okay, there are many ways to provide a cloud for you, all right. So please, okay, make sure that you, okay, create your group, okay. I hope you can create your group here for chapter, okay, for I go to the, this one is section 2. Let's we go to section 3. All right, so let's we go to section 3. All right, so I stop sharing. Okay, I go to the stop sharing. I go to another section. All right, so if I can go to the another section, come on. All right. Okay, this is a section 3. All right. Oh, Alhamdulillah. Okay, already done. Okay, thank you very much. Okay, all right. Group 6. Oh, which is group 6 or group what? Group 6. Okay, group 6. Okay, leader is Izatul Fitri. All right. Okay, you can see here. Okay, very clear how your friend create a group here on time, real time. All right. So I go to my system. Okay, Muhammad Khairunas, okay, Muhammad Afif, and Muhammad Fikri. How many now? 1, 2, 3, 4, 5. Muhammad Firdaus on. Okay, very good. All right, so how about the group in chapter 5? Okay, chapter 5 is Ifa Shazwina, leader. Okay, thank you very much, leader. Okay, and then Siti Rokaya, Muhammad Asri, Muhammad Rafiq, and another one. Okay, you have at one more for group 5. All right, so now group 2 is still working. Okay, working group 2. Okay, the leader they still don't know. It's a Noor Izzati, but the member is a Noor Hazrina and Shazwan. Very good. Okay, thank you very much. All right, I provide you a group here. All right, just the group 5 now, real time, Azima. All right, Azhima. All right, okay, come on. This enough for group 5. So please, okay, you work together, and then you need to submit the assignment, the exercises in the group. You can discuss in your group and post in the real time. 50 minutes we give you to solve this problem. You will ask me why? Because we want to avoid the issues at CHEGG site, where there is a live online tutoring near to your eyes to give you an answer. That's why, okay, I don't want you spend money to go to other site to pay for their live tutor. All right, so we give you a time duration to solve this problem. All right, so please put your name. This is to confirm your QR code attendance. All right. So now we go to group 3. Wow, group 3. Okay, group 3 is finding a friend. Amirul Liman. Okay, Muhammad Shafi. Okay, Carol, and Intan Nur Hanim. All right, thank you very much. All right, this is a group 3. How about other group? You can add group. Okay, you can add group here. Say this one is a group. Okay, group 5. Okay, all right, so I go to here and save. All right, so you can create a group here. All right, it's depend on the section 3 now is only have 30 plus student. All right, so you can add in. Okay, one group is only 5 student. All right, thank you very much. Okay, so this is considered is a real time. Okay, of the class. Okay, thank you very much. I give you a time until 9:15 to confirm your attendance today. All right, to confirm your attendance today. So why? Okay, why not tomorrow? Why not yesterday? Okay, why not another day? All right, because we want to confirm your attendance real time. If you have a network problem, all right, we already checked your network yesterday. All right, who are very minimum bandwidth, you can go to the location in your house, or please post your problem to your group and your group will help you. All right, so why we need a group? Because we have a problem, for example, network problem, your computer device problem, your cloud problem, and then your system that you handle. For example, we have a Padlet problem. So there is so many alternative. If many things problem, for example, hacker, data breach, data leak, we have so many alternatives. Don't worry, because nowadays as a mathematician, we have to get another skill we call as hacking skill. All right, so not to hack people, but go to my video. The last session is what is that? Three. Okay, three philosophy when we deal online is what? Is a literacy. The life is different. You can work through online real time. All right. And then the second is you deal with the data, and then how you ethical to the data, honestly to the data, and then integrity value. The second is the competent, how competent you are. All right, so see how competent you are. You can create a group, for example, group 5. Wow, come on, group 5. Okay, you can add column here. Okay, you can go to group 7. Okay, the group 7. All right, group 7, for example. All right, so group 5 is Afifa, Sumaya, Sarah, and Sabrina. Please put the the full name, because I want to tick at the attendance. All right, please put the full names. Okay, thank you very much. Okay, you can create to group 6 and group 7 and others. Okay, you can create by your own. Okay, I will go to the group and then correct the system. Never mind. All right, so this is one way, okay, to make it more fast. Okay, get feedback from the student. So if you have a problem, you can work in the group. If you have a problem, what cloud problem, okay, network being network bandwidth problem, okay, internet problem, system problem, all right, or device problem, your handphone problem, your laptop problem. All right, so this is one of the way. Okay, dah buat, doktor. Thank you very much. Okay, Noor Hafiza, thank you very much. Okay, they said that I cannot edit. Okay, I cannot edit. Actually, you just put positive here. Okay, you cannot edit. Yeah, all right. So if you cannot edit, so I will edit for you. I will prepare the column for you. All right. So let's say okay, I put another column. Okay, I thought you can add column. Okay, this one I put the group. Okay, maybe I put group 8. All right, to make it more different. All right, and then I put group add here. Okay, group group 9, for example, here, and then maybe we can get a group. Okay, I think enough. I think group 10. All right, so I just put here. Okay, we are missing group 6 here because group 6 already done by somebody here. All right, so I hope I can edit here. I put as a edit group 4. Right, I put as a group 4. All right, this one is I edit here. All right, I put as a group 5. All right, group 5. All right, and then this one is a group 2, and then this one is a group 5. This one, it should be group 1. Okay, edit here. All right. Okay, I'll just put your own group. Okay, group 1 here. All right, so let's we go here. It's a group 1. Okay, this one is a group 3, group 2. Okay, if I can change here, edit. Okay, edit post group 2. All right, so there are so many ways to find your group. Okay, keep calling your friend. All right, we want to make sure that you're working in the group. All right, and then post your real time here. All right, so now, okay, dah boleh dah, doktor. All right, so dah boleh dah. Okay, thank you very much. So means that you get used with the system. Thank you very much. All right, so I'm waiting you at the Padlet till 9:30. Till 9:30. All right, so thank you very much. Okay, ends now. Okay, bye-bye.